class, you guys did a whole unit on quadratic equations. And that's okay. When you guys did quadratic equations, when you guys worked with quadratic equations, you guys first learned how to work with them via graphs. And you spent quite a bit of time graphing them, plotting points, making tables, and doing all that other stuff. And then eventually, you learned shortcuts of doing things. You kind of went through the same process of understanding what it meant to have a quadratic function. For example, you guys were given a quadratic function, more often than not, written in the form f of x, or y equals ax squared plus bx plus c. This is the standard form of a quadratic equation. You can use f of x or y equals. They're both working just fine because every quadratic equation is, or an x squared quadratic equation, I say, is always a function. So you don't have to worry about that. From just looking at that information, there's a couple of things that you should remember. Details about a graph. What's something you can tell me about the graph just looking at the A, B, and C? It's going to be a parabola. Okay, it's going to be a parabola because of the squared part, not because of the A, B, and C. Up or down, okay? How do you know it's up or down? Which is positive? A, B, or C? Which is it? A? All right, well, you go to the Hall of Fame for batting 333 over your career, so I'll give you that. You got lucky. He's right. If the value of A is positive, if your A value, the leading coefficient of the x squared, if you will, if your A value is positive, it was up like a cup. Remember that? If the A value was negative, it was down like a frown. The value of A denotes direction. It tells you what direction your graph is going. This occurs in just about every one of the graphs we look at. Remember we had absolute value? We had A times the absolute value of x minus h plus k. If the A value was positive, the B would, bless you, if the B value was up and down, put away the Chromebook. If the A value was negative, it was moving downward, the B opened downward. That A value, for most of our functions that we look at, if there is an A, B, and a C, it's going to tell us direction. When we get to trigonometric functions, the A value is going to tell you if you start moving upward first or you're going to start moving downward first. It tells you your first step for graphs. It tells you which way things are moving. What do you think the value of C gets you? Very good. The value of C will always give you your y-intercept because at your y-intercept, what's always your value of x? 0. So if I throw in 0 for x, I'm going to get 0 plus 0, which is 0. So the C value is always your y-intercept. Now, what's nice about knowing that is, let's say you forget that if your A value is positive, you actually draw it negative, but your C value is up here. Well, you know you done goofed. You can't use the catchphrase. All right, you know you screwed something up. So just understanding some very small pieces of this, you can get some stuff done. Also, you learned that within every parabola, there was this imaginary line. What was that imaginary line called? Man, you guys are smart. The axis of symmetry. The axis of symmetry is the value where everything on the left matches to everything on the right, and vice versa. What happens here is that every point that's on the graph is equidistant this value and this value is always the same. That value is congruent. Points on the parabola opposite one another have to be, well, they're always going to be straight across from one another, but also they're going to be equidistant. So this axis of symmetry, we're going to call this an AOS. It always goes through one part of your graph. What was that part called? Okay, it's a minimum or maximum, but the minimum or maximum, is located where? Top or bottom, okay, but what is that point called? The vertex. You guys remember that? I didn't hear you. Okay, I'm sorry. Oh, well, congrats. This is called the vertex. The vertex. The vertex of every parabola is either a maximum or a minimum. This case, in this drawing, what is it? It's a minimum. When you are up like a cup, you have a low spot. That is a minimum. If you are down like a frown, you have a maximum. This is the high spot. Now, axis of symmetry is a vertical line. Do you guys agree? It's an imaginary vertical line. That's why I draw it dotted. What is the equation of every vertical line? X equals something. Now, doesn't that mean that your vertex, this value here, is your axis of symmetry? Remember how to find that? Using your... How do I find the axis of symmetry in that? Remember that? It's got A's and B's in it. So your axis symmetry is always going to be located at the value x equals the opposite of b over 2a. The axis of symmetry will always be located at the equation at the of x equals, because it's vertical, the opposite of b over 2a. So that this value here is always the x coordinate of your vertex. If you didn't know your y coordinate, you would just substitute that into the function to find it. Okay? There's a lot of little quick things that happen here. Okay? A lot of little quick things. For example, when I'm working with quadratics, or I'm working with, we did absolute value stuff. We had ABs, and we had the absolute value, we had H's and K's. We like to label everything so we know what parts go where. I like to do that also with these things because it allows us to be able to visualize what in the world's going on easier. Okay? For example, let's say we have the, can I go to a clean one real quick and we'll walk through one? Let's say we have, nope. Let's say we have y equals, let's see, x squared, trying to do this in my head, plus 9, no, we'll do 8x plus 12. Say we have that. And I want to graph it. I'm going to walk you through how I like to see you guys graph these things. What that means. Graph paper. So take a couple of sheets. Trigonometric proofs. Did I show you what those look like? I'll show you later. Go ahead. Like the sine squared, cosine squared stuff. Okay. Yeah, just take two. Save one for your notes and save one for homework. We got about a couple of these for tonight. So, when I'm working with quadratics, and you guys can just hold on to the ones in the back, that's fine. When I'm working with quadratics, what I like to do is always start by listing out everything that I can get from the original function. In this case, we have y equals x squared plus 8x plus 12. So what I want to do is label what's my a value, what's my b value, what's my c value. Okay? In this case, what's your value of a? 1. Is it positive or negative? It's 1, it's positive, so is this up like a cup or down like a frown? Up like a cup, which means our vertex is going to be a minimum. So what I'm doing right away is that I'm taking care of the idea that I know that when I'm done, just from looking at that value of a, my graph better be pointing upward. Because I know it has to, because that's the rule. A value is positive, it's got to open upward right off the bat. What's my b value? My b value is 8, and the c value, therefore, last but not least, is 12. Now, from there, the first thing I'm always going to graph is my axis of symmetry. Remember, your axis of symmetry is always located at the value of where x equals the opposite of b over 2a. I'm going to suggest that when you're doing axis of symmetry, and then later on when we talk about quadratic formula or any of our other shortcut stuff, write out the formula a couple of times. It'll be in your head in no time. Axis of symmetry is pretty quick and painless. Opposite of b over 2a. You'll get used to that over the course of like 3 problems. So what's the opposite of 8? Negative 8. So what I do is it's going to equal negative 8 divided by 2 times 1, otherwise known as negative 4. Oh, I saw you're getting 2. Sorry, 2 times 1. Okay. So that means my axis of symmetry is at the vertical line, the vertical imaginary line of x equals negative 4. Remember, this vertical line isn't technically part of the true parabola function. It's there to help us align it cleaner. So we just draw a dotted line at x equals negative 4. And since I know my vertex has to be located at negative 4 comma something, now I just got to figure out what it equals. So what's negative 4 squared? 16. What's 8 times negative 4? All I'm doing is substituting into the function for x. So negative 16 minus 32 is, add 12 to it, you get negative 4. So that means my vertex is located at the ordered pair, negative 4, negative 4. And it's a good thing that we've already discovered that we know the y-intercept is up there at 12. So I know that my vertex being below my y-intercept is a good sign because it's got to rise to reach it. So we know that we haven't screwed something up yet. There's still time, but we have. From here, it's just a matter of picking points. And normally all I do is just pick the next 2 points either to the left or to the right of the value, whichever direction is easier to do mental math. Because more often than not, that's all you have to worry about. Like, for example, what's negative 3 squared? 9. What's 9 plus negative, what's 9 and 12? 21. What's negative 24 plus 21? So wouldn't that be a negative 3, negative 3? I'm just picking points. I'm plotting. Remember how you used to graph? You would just make tables? That's how you learn how to graph. Pick a value of x, substitute in the function, you're chugging out y. All I'm doing is I'm picking points. I'm just doing mental math. Negative 3 squared plus 8 times negative 3 plus 12. Okay. You're using mental math. All right. This math. I'm substituting negative 3 in the function. So What I want you to see is, all I'm doing is picking a value of x. You can pick any number you want. I'm picking the next number because it's usually it usually will show up on the graph pretty cleanly. And you just go from there. Since -3 is one spot to the right of our axis of symmetry, what's one spot to the left of our axis of symmetry? -5. So what do you think -5 is going to have to be? It has to be at -3 because they have to be symmetrical. It's symmetric twin. They're equidistant. All right. Let's do -2. -2 quantity squared plus 8 times -2 plus 12. -2 squared is 4. 8 times -2 is -16, so that gets me -12. -12 plus 12 is 0. So at -2, I'm 0, which means at -6, I should also be 0. Because they're symmetric twins. They have to be the same distance to the axis of symmetry. And that's all I usually ask you guys to do is 2 points on either side. And there you go. And that's what your graph would look like. Again, this is all the process by which you guys learned back in Algebra 1. Maybe didn't talk as much as the vocabulary of it, but that's how we did that. Okay? But in Algebra 2, it just means that there's more ways of doing things. Which means we have to look at other processes, other ways that graphs can be looked at. For example, can I go to clean one here real quick? Hold it. There's 2 other ways we're going to look at graphing these today, depending upon how you're given the formulas. The next one is called vertex form.